differential equation is said to be linear if its degree is 1 and if it does not contain a product term between the dependent variable y and its derivative.
It is an equation that can be expressed in the form dy over dx plus p of x times y is equals to q of x if it is linear in y, and dx over dy plus p of y times x is equal to q of y if it is linear in x. If it is linear in y, use the formula y times e raised to the integral of px dx is equal to the integral of q of x times e raised to the integral of p of x dx times dx, where e raised to the integral of p of x dx is our integrating factor. And if it is linear in x, use the formula x times e raised to the integral of py dy is equal to the integral of qy times e raised to the integral of py dy times dy, where e raised to the integral of py dy is our integrating factor. There are steps to solve a linear DE. First is to express or transform the given equation into a standard form. Next is to solve for the integrating factor. And lastly is to solve for the general solution or the particular solution if x and y values are indicated. Example number 1, dy is equals to x minus 3y dx. So first is to transform this equation into a standard form. We will divide both sides by 1 over dx to eliminate the x here. This will become dy over dx is equal to x minus 3y. We will transpose negative 3y to the left side. This will become dy over dx plus 3y is equals to x. So this is now our standard form, which is our equation is linear in y. Next step is to solve for our integrating factor, which is e raised to the integral of p of x dx. So e raised to the integral, the value of our p of x is 3. This is our p of x, and x here is our q of x. So e raised to the integral of 3 dx. Our integrating factor is equals to e raised to the power of 3x. So next is to solve for the general solution using the formula y times the integrating factor, which is e raised to the power of 3x, is equal to the integral of q of x times our integrating factor, which is e raised to the power of 3x dx. So this will become y e raised to the power of 3x is equal to the integral of q of x, which is x, times e raised to the power of 3x dx. So we will now proceed to integration. This is integration by parts. We will let u is equals to x, du is equals to dx, dv is equals to e raised to the power of 3x dx, and our v is equals to e raised to the power of is 1/3 times e raised to the power of 3x. This will become y e raised to the power of 3x is equal to, and the formula for integration by parts is the integral of v du is equals to uv minus the integral of v d. This is u dv and this is v du. So the value of our u is equals to x times v, which is 1/3 times e raised to the power of 3x, minus the integral of v du, which is our v is 1/3 of e raised to the power of 3x, and our du is equals to 3 dx. So this will become y e raised to the power of 3x is equal to 1/3 x raised to the power x times e raised to the power of 3x, minus, we can put this 1/3 outside the integral sign since this is a constant. So minus 1/3 times the integral of e raised to the power of 3x dx. So simplify, this will become y e raised to the power of 3x equals to 1/3 x e raised to the power of 3x minus 1/3, and the integral of e raised to the power of 3x is 1/3 e raised to the power of 3x plus c. So simplify again, y e raised to the power of 3x is equals to 1/3 x times e raised to the power of 3x minus 1/9 times e raised to the power of 3x plus c. So we will multiply both sides by 9 to eliminate 9 here. So this will become 9y e raised to the power of 3x is equals to 3x e raised to the power of 3x minus e raised to the power of 3x plus c. Since all of our terms here contains e raised to the power of 3x, we will divide both sides by e raised to the power of 3x. This will become 9y is equals to 3x minus 1 plus c over e raised to the power of 3x. So this can be rewritten to 9y is equals to 3x minus 1 plus c times e raised to the power of negative 3x. So this is now our final answer. Example number 2, y minus x plus xy cot x dx plus x dy is equal to 0. So first, let us transform this equation into standard form. First, we will divide both sides by 1 over dx. To eliminate dx here, so this will become y minus x plus xy cot x plus x dy over dx is equals to 0. And then we will transpose negative x to the right side. This will become y plus xy cot x plus x dy over dx is equals to x. And then we can rewrite this into x dy over dx plus y plus xy cot x is equals to x. And then simplify xy dx factor y. This will become 1 plus x cot x is equals to x. And now we can divide both sides by 1 over x. To eliminate x here, this will become dy over dx plus 1 over x plus cot x times y is equals to 1. And next step is to solve for our integrating factor, which is e raised to the integral of p of x dx. And our p of x here is this one. This is the value of our p of x, which is 1 over x plus cot x. And then our q of x is 1. So this will become e raised to the integral of 1 over x plus cot x dx. So the integral of 1 over x is ln x plus, and the integral of cot x is ln sine x. So this is equal to e raised to the power of ln x times e raised to the power of ln sine x, which is equal to x times sine x. So next is to solve for the general solution by using the formula y times the integrating factor e raised to the power of p of x dx is equals to the integral of q of x times the integrating factor e raised to the power of p of x dx times dx. So copy y, and our integrating factor is x sine x is equals to the integral of, this will become 1, the value of our q of x, and then copy our integrating factor, which is x times sine x dx. Then we can rewrite this into xy sine x is equals to the integral of x sine x dx. And then proceed to integration by parts. We will let u is equals to x, du is equals to dx, dv is equals to sine x dx, and then v is equals to negative cos x. So this will become xy sine x, and then the formula for integration by parts is the integral of u dv is equals to uv minus the integral of v du. So u, our value for u is x, and then v is negative cos x minus the integral of v, negative cos x, then du dx. Simplify. This will become negative x cos x plus the integral of cos x dx, which is, copy x, the integral of our cos x is sine x plus c. So this is now our final answer. Example number 3, y minus cos squared x dx plus cos x dy is equals to 0. So first is to substitute this dx to our inner term. This will become y dx minus cos squared x dx plus cos x dy is equals to 0. And then we can eliminate both dx here by dividing both sides by 1 over dx. This will become y minus cos squared x plus cos x dy over dx is equals to 0. So we can rewrite this into cos x dy over dx plus y is equals to cos squared x. So we just transpose this to the right side, and then we can simplify by dividing both sides by 1 over cos x. So this will become dy over dx plus 1 over cos x times y is equals to cos x. And as you can see, this is now the standard form of our equation, which is, our equation is linear in y. Next is to solve for the integrating factor. Our integrating factor is e raised to the integral of p of x dx, and our p of x here is equals to 1 over cos x, and our cos x is our q of x. So e raised to the integral of p of x, which is 1 over cos x dx, and the value of our integrating factor is, so 1 over cos x can be rewritten into 1. This is equal to sec x dx. So our integrating factor is equals to, the integral of sec x is ln sec x plus tan x. So we can eliminate this, and the remaining value is sec x plus tan x. So to get the general solution, we use the formula y, the integrating factor, e raised to the power of the integral of p of x dx is equals to the integral of q of x times e raised to the power of the integral of p of x dx times dx. So our y, I copy y, and then the value of our integrating factor is sec x plus tan x is equals to the integral of q of x. Our q of x is cos x times the integrating factor, which is sec x plus tan x dx. Copy y times sec x plus tan x, and then distribute cos x to our inner term. This will become cos x times sec x dx plus the integral of cos x times tan x dx. So copy y, sec x plus tan x is equals to cos x, and then we can rewrite sec x to 1 over cos x dx plus cos x, and tan x is also equivalent to sin x over cos x dx. So this will become y sec x plus tan x is equals to, so this is cancelled, so the remaining value is 1 dx plus the integral of, this is also cancelled, sin x dx. So we can now integrate, copy y sec x plus tan x is equals to x plus, and the integral of sin x is equals to negative cos x plus c. So this is now our final answer. So we are now down to our last example, y dx plus 3x minus xy plus 2 dy is equals to 0. So first, let us substitute dy to our inner term. This will become y dx plus 3x dy minus xy dy plus 2 dy is equals to 0. This will become 1y dx, and then let us factor out x and dy. This will become x times 3 minus y times dy, and then we transpose 2 dy to the right side. This will become negative 2 dy. And then to eliminate y and dy here, we divide both sides by y dy. So this will become dx over dy plus x. This will become 3 minus y over y is equals to negative 2 over y. And then dx over dy plus x. So we can rewrite this into 3 over y minus y over y is equals to negative 2 over y. So this will become dx over dy plus x times 3 over y minus 1, because this is equal to 1, is equals to negative 2 over y. So this is now our standard form. Our equation is linear in x. So next is to solve for the integrating factor e raised to the integral of p of y dy. And then the value of our p of y dy is equals to 3 over y minus 1. So this is our p of y. And the negative 2 over y is our q of y. So this will become e raised to the integral of p of y 3 over y minus 1 dy. So the integral of 3 over y is equals to 3 ln y, and the integral of negative 1 dy is equals to negative y. And then we can rewrite this into 3 i.e. raised to the power of ln y cubed times e raised to the power of negative y. So this will become y cubed times e raised to the power of negative y. So this is the value of our integrating factor. And to solve for the general solution, we use the formula x, since our equation is linear in x, times the integrating factor of e raised to the integral of p of y dy is equal to the integral of q of y times the integrating factor of e raised to the integral of p of y dy times dy. Copy x, and the value of our integrating factor is y cubed times e raised to the power of negative y is equals to the integral of q of y, which is the value of our q of y is negative 2 over y, times e times the value of our integrating factor, which is y cubed times e raised to the power of negative y dy. And then this will become x y cubed times e raised to the power of negative y is equals to, since this is constant, we can put this outside the integral sign. So this will become negative 2, and this will become y cubed over y times e raised to the power of negative y dy. So copy xy cubed times e raised to the power of negative y is equals to negative 2. We can simplify this by subtracting the exponent. This will become y squared times e raised to the power of negative y dy. So we can now proceed to integration. Copy xy cubed times e raised to the power of negative y is equals to negative 2. So this is integration by parts. We will let u is equals to y squared, du is equals to 2y dy, dv is equals to e raised to the power of negative y and our negative y dy, and our v is equals to negative e raised to the power of negative y. So the formula of integration by parts is the integral of u dv is equals to uv minus the integral of v du. So this will become, the value of our u is y squared, and our v is negative e raised to the power of negative y minus the integral of v du, negative e raised to the power of negative y, and our du is equals to 2y dy. Copy xy cubed times e raised to the power of negative y is equals to negative 2 times negative y times negative y squared e raised to the power of negative y plus, so we will put 2 outside the integral sign since this is constant, times the integral of e raised to the power of negative y times y dy. So next is xy cubed times e raised from negative y is equals to, we will substitute negative 2 to our inner term. This will become positive 2y squared e raised from negative y minus 4 times the integral of e raised to the power of negative y times y dy. So we will still proceed to integration. We will let u is equals to y, du is equals to dy, dv is equals to e raised to the power of negative y dy, and then v is equals to negative e raised to the power of negative y. So x y cubed times e raised to the power of negative y is equals to 2y squared times e raised to the power of negative y minus 4 times, so times uv, which is our u is y, and our v is equals to negative e raised to the power of negative y minus v du, which is our v is negative e raised to the power of negative y, and our du is dy. So this will become x y cubed times e raised to the power of negative y is equals to 2y squared times e raised to the power of negative y. We will substitute negative 4 to our inner terms. This will become plus 4y e raised to the power of negative y minus 4 times the integral of e raised to the power of negative y dy. Simplify, this will become xy cubed times e raised to the power of negative y is equals to 2y squared times e raised to the power of negative y plus 4y e raised to the power of negative y minus 4, and the integral of e raised to the power of negative y is negative e raised to the power of negative y plus c. So this will become xy cubed times e raised to the power of negative y is equals to 2y squared times e raised to the power of negative y plus 4y times e raised to the power of negative y plus 4 e raised to the power of negative y plus c. Since all of our terms here contains e raised to the power of negative y, we will simplify our equation by dividing both sides by e raised to the power of negative y. So this will become xy cubed is equals to 2y squared plus 4y plus 4 plus c over e raised to the power of negative y. And we can rewrite this into xy cubed is equals to 2y squared plus 4y plus 4 plus c times e raised to the power of y. And this is now our final answer.